Hello and welcome. Today, we're going to peek behind the curtain at something we almost never see, but we definitely feel it every day: the air ducts that keep our homes and buildings so comfortable. We're going to explore this hidden system that brings us cool air in the summer and keeps us warm in the winter.
Really think about it for a second. You feel that nice, cool breeze from a vent, whether you're in a huge office building or just in your living room. How did that air get right there to that exact spot? Well, that's the magic we're going to uncover today, and you'll see it's actually more interesting than you might think. All right, so here's our game plan. First, we're going to start with the absolute basics. What even is an air duct? Then we'll get into the simple physics of how it all works. After that, we'll dive into the different ways ducts are classified. I promise, by the end of this, you'll look at those vents on the wall in a whole new way.
Okay, let's start with the most fundamental question to get us all on the same page.
So what is an air duct? The easiest way to think about it is like a hallway, but for air. Its main job is to take that conditioned air, air that's been cooled down or heated up or filtered, and carry it from your main furnace or AC unit to every single room in the building. It's basically a guide, making sure the air goes exactly where it's supposed to. So now we know what they are, but how do they actually work? How does the air get from point A to point B? Well, it all comes down to a really, really simple rule of physics. This right here, this is the golden rule. Seriously, everything about how air ducts work boils down to this single, simple principle. Air wants to move from a place with high pressure to a place with low pressure. That's it. The entire HVAC system is just a clever machine for creating and controlling that pressure difference. So the big question is, how do we create that pressure difference? Simple, with a fan. When the fan inside your HVAC unit kicks on, it's basically like a pump. It pushes air forward, which creates a high-pressure zone right in front of it. And behind it, you guessed it, a low-pressure zone. So the air, just following the laws of physics, naturally flows from that high-pressure spot through the ducts toward the low-pressure spot. Simple as that. Excellent. So now we know what ducts are and how the air moves through them. Now let's look at how we classify them. The first way is by thinking about their specific job, or what we call their application. So there are 4 main jobs a duct can have. First, you have supply ducts. These are the ones that bring the good stuff, the cool or warm air, to you. Then you have recirculating ducts, which take the used air from the room back to the main unit to get treated all over again. Fresh air ducts pull brand new air in from outside, and finally, exhaust ducts do the exact opposite. They push stale, old air completely out of the building. All right, on to the next one. Another way we can classify ducts is by how fast the air inside them is moving. And believe it or not, this is a really important detail when designing a system. We measure airspeed here in FPM, which just stands for feet per minute. Now, a low-velocity system, where the air is moving under 2,000 FPM, is fantastic because it's super quiet and efficient. High-velocity systems, on the other hand, can cram a lot more air through smaller ducts, which saves space. But the trade-off is usually more noise, because faster air creates more whooshing sounds. And of course, medium velocity is just that sweet spot right in the middle. And this really highlights a key trade-off in HVAC design. In a low-velocity system, since the air is moving slower, there's less friction against the walls of the duct. Less friction means less energy is lost, which makes them way more efficient. The only catch is that to move the same amount of air, the duct itself has to be physically bigger, which can take up a lot more space. Okay, let's talk about our third and final classification. This one connects right back to that golden rule of physics we learned earlier. We can also categorize ducts based on the amount of pressure or force the air inside it has. Now, the unit here might look a little weird. Inches of water column. It's just a very precise way that engineers measure air pressure. For most homes or small offices, you're going to have a low-pressure system. But for huge buildings that need to move air across really long distances, you'll find high-pressure systems, which, as you can imagine, need much, much more powerful fans to generate all that force. So that's our little journey through the unseen world of air ducts. We've talked about what they are, the physics behind them, and all the different ways to classify them. Let's do a quick recap of the key points. The most important things to remember are these 3 questions. When you're thinking about any duct system, you can just ask, what is its job? Is it supplying air or exhausting it? How fast is that air moving? And finally, how much pressure is it under? If you can answer those 3 things, you know pretty much everything you need to know about that part of the building's hidden network. And that leaves us with a final thought.
The next time you're sitting somewhere, a library, your office, or just on your couch, and you feel that gentle stream of air, take a second to think. Based on everything you just learned, what kind of system do you think is at work, right behind that wall, keeping you comfortable? Is it maybe a low-velocity supply duct? Something to think about. Thanks so much for joining me today.